In Chapter 7, Section 3, we're reminded that if we don't have a standard deviation, if we're not given the population standard deviation, we can use the sample standard deviation up to a point using a t-test. So we're going to do that for the IQs of famous people. So I'm going to copy that data, and then I'm going to open a GeoGebra spreadsheet. I'm going to go into View, turn on Spreadsheet, turn off Graphics and Algebra. I'm then going to paste that data in. Now the first thing you'll notice is that we only have 20 data points, but we're allowed to remember that the IQ scores, when they're randomly selected, are normally distributed. So that's sufficient for that part of the test. So let's go into one variable statistics, and then let's get our statistics, and let's go down to a t-test of a mean. So we went into statistics using the sum of x, and then we selected the t-test for mean. This has to be a t-test because we do not have a population standard deviation. Now notice that because we're using the spreadsheet, GeoGebra knows what the sample standard deviation is. Now let's remind ourselves what the question is. It says, from the website of IQ of famous people, a random number generator was used to pick a sample of 20. So these are IQs. They're randomly selected, so we can assume they're normally distributed. And does the data provide evidence at the 5% level that the IQ of a famous person is higher than the average IQ of 100? So we're told that the average IQ is 100, and we're interested in testing if this is in fact higher. So let's see what we can do. The null hypothesis is that we're equal to the population mean of 100, but looking at this data, we claim that it might be more. So here's our p, and here's our p-value is essentially 0, and our t-score is approximately 7.